Hello, everyone. Thank you very much for Dyndrite for having us here today. I'm Nicholas Nadeau, the engineering manager at AON3D. And AON3D is more than just an industrial 3D printer manufacturer. We provide the full cycle solutions that help customers get from 3D model to final part. And today I want to talk about why that offering and why making materials matter is more relevant than ever. And so we're in the middle of an explosion in our collective understanding of the future of manufacturing, and this COVID-19 pandemic has highlighted the need for 3 key points that any manufacturing company needs to consider when trying to respond with lightning agility to a crisis. And so the first is rapid prototyping. Major events like this shift demand patterns that require companies to adapt with incredible speed. And there are few technologies that offer the same opportunity for rapid development of prototypes and new products or parts like 3D printing can. And this is actually a fantastic example we have here of the accessibility that 3D printing offers a wide range of engineers. And so the student design team that built this part, it's a dashboard for their electric Formula One race car, was able to access high performance materials like the carbon fiber peak used here and achieve the geometric complexity that you can see in this shape and form. And so that means a second-year engineering student has access to the same materials as an Air Force research scientist. Now, the second aspect is agile manufacturing, and to remain nimble in an economy that is increasingly demanding of agility from manufacturers and product developers, and sometimes throws crazy events at you like this COVID pandemic, ensuring that you could respond quickly to signals from the market as well as changes in your supply chain will be essential for business continuity. And finally, we have supply chain diversification and integrity. And as demand patterns have shifted and suppliers are even being mandated to focus their attention inward on their local economies, we're seeing one of the pitfalls of globalization. So to maintain that integrity, companies are realizing that the value of ensuring they have multiple suppliers and an open market that can rely on their materials and parts, rather than close off their supply chain for the risks through the risk of sole sourcing. And that leads us to additive manufacturing, aka 3D printing, as the technology offers the foundation that enables agile manufacturing and rapid prototyping. And this ability to rapidly iterate your designs, print prototype parts, and then bridge the short to medium term or low to medium volume production gap with 3D printing before kicking in traditional manufacturing, this is the game changer. But the third component of supply chain requires something essential. Not all manufacturing technologies or even 3D printing systems can offer what you need to protect your supply chain. And so supply chain integrity requires manufacturers to have a choice. Everything comes from that. And when a manufacturer has a choice, rather than being locked into a single supplier, that not only provides the value of open market price competition, but also the supply chain integrity of being able to move between suppliers when required, such as when a pandemic throws a global supply chain into complete disarray. And we further improve the ROI for customers by pairing that materials pricing advantage of the open market with a machine that has an affordable cost. And in the 3D printing world, this open source approach to materials is part of our commitment to our customers and our commitment to unlocking more options and making materials matter. Rather than a closed source system where users are required to use the pricey proprietary materials sold by the OEM, we are committed to building the most versatile open materials 3D printing platform. And our customers can choose from hundreds of materials from leading suppliers, accomplish more applications with a wider range of materials, and respond with agile manufacturing practices to a crisis that affects their supply chain. And so we have a very recent and relevant example of how this agility was invaluable in helping to save lives from the COVID pandemic. One of our customers, Brian Gillett, working out of NYU Withdrawal Hospital, needed a way to produce valves that would convert BiPAP machines, which are used to maintain breathing patterns in COPD patients, into ventilators. And they needed another option to rapidly increase the ventilator capacity in their local hospitals that would also produce parts with material that could withstand autoclaving temperatures so that it could be sterilized for reuse. They'd already tried SLA 3D printing, but the materials available to them and the SLA 3D printers could not produce parts that could be autoclaved and were also fragile and pretty brittle. And so we responded immediately and supported Brian in selecting PEK, polyether ketone ketone, a relative of PEEK, which many of you have probably heard of, And this is an ultra high performance thermoplastic that can stand up to autoclaving temperatures, has great printability, and satisfy the requirements for their application. And so the customer had no previous experience printing this material. So they got in touch with our customer success team, who provide the next key advantage that AON offers: full cycle customer success plans that add our 3D printing expertise to the customer's toolkit, so they could get the part that they want with the properties they need much faster. And we advised Brian on the material selection, how to set up the part in the slicer, and within a day, we had provided everything they needed, and the print came out right the first time. From there, we helped the customer iterate on their design so they could print the part with the same robustness, but using less material. And now Brian and his colleagues were able to meet the immediate needs of their hospital so they could max out their BiPAP usage and save lives. And once again, another example, face shields. The agility provided by open materials and industrial 3D printers, when they're paired with the support that the customers needs to rapidly iterate and achieve their applications, is demonstrated in our recent example with COVID-19 and our partnership with the Montreal University Health Center. We received a request 3-ish weeks ago from a local anesthesiologist, Dr. Avi Sina, and on March 24th, the hospital was running desperately low on PPE and needed face shields to help protect their healthcare workers. And drawing from an open source design provided by the researchers at Georgia Tech, we adapted the design within 2 hours. 72 hours later, we had tested several prototypes at the hospital, arrived at a final version, and now hundreds of our face shields are being used at hospitals and health centers and long-term care facilities around Montreal and beyond. And we couldn't produce and distributed these hundreds of face shields in that first week without additive technology. And 3D printing plays an essential role in this first line of defense when prototyping and moving to agile manufacturing practices. And now we're working with laser cutters and injection molding to rapidly increase the volume and the scale that we can produce. But moving to these higher throughput technologies would have been absolutely impossible on the time scale we achieved without advanced 3D printing and an open material system. And additive manufacturing is an essential tool for any organization that needs the right parts with the right properties on a fast timeline. It also provides an essential bridge to other conventional manufacturing technologies that can't iterate with the same speed that 3D printers can. And I want to acknowledge that the important story here is the heroism of our frontline workers. The lessons that business leaders in technology, manufacturing, and product development need to take away from this event is that the advanced additive manufacturing machines are the gateway to turning the Titanic, to making massive changes in your production systems that rapidly get you the part you need with the properties you want. And the only way you can achieve that speed is by ensuring that you have the choice to keep your supply chain humming. And finally, ensure that you're not going in this alone. Invest in expertise to help ensure that you approach each application with the knowledge that helps you achieve it faster. And in this regard, I want to emphasize that companies should be careful in considering their investment in 3D printing. Ensure that you have a machine that has the specs to print a wide range of thermoplastics. Now, our flagship machine, the AON3D2020, the industrial 3D printer, offers an actively heated bed, build chamber, 2 independent tool heads, and an engineered convective float path for maintaining the isothermal conditions you need to achieve those ideal part properties, especially at the high performance range. And more than that, ensure that you're working with a company that can support you in achieving your applications. At AON3D, we're more than just a 3D printer manufacturer. We offer from comprehensive training to design for additive to material selection to slicer file optimization and print process parameter development. We support you in getting from 3D model to final part. Our adaptive face shield design is available and open source, and you can find the link to it on our website. And for anyone who's interested in learning how additive manufacturing can accomplish your next application, please get in touch with us at aon3d.com. We have a free webinar with tips on 3D printing the strongest thermoplastics like PEEK, PEC, and Ultim, and we encourage you to check that out. We'll be having a vendor lounge meetup after this that Dyndrite will link, and I want to thank you all for your time, and I'd love to take any questions.
All right, thank you, Nicholas. That was a great presentation. Especially appreciate you guys moving on those relief efforts. I did have one question. How did you communicate, or what did you learn in communicating with frontline workers in order to act quickly on your response?
So the number one lesson I learned, and this has been going back and forth, and I want to call it the user story, and why rapid iteration up front in your design process with your users is probably the most important thing. The doctors that we're designing this for are just pleased, happy, and overjoyed in having face masks designed with their input. One of the biggest critiques they've given us in the past is all the equipment they've been given has been given to them. They've never been involved in the design process and have never had a tool designed for their current needs right now in this situation.
Thank you for doing that and mentioning the involvement in the design process. That's critical for any product we're designing. Another thing that's pretty unique to AON3D is your open materials approach. Could you tell us more about why that's important moving forward?
So very important moving forward. I came from a medical background. I had 3D printers for the past decade doing medical implants. And then one day I want to start using a new material, and the platform I was using, that was locked out. And so what we're really looking for is unlocking that design potential for the designers, for the engineers that are designing the part, and not limiting their design scope just because of the machine they're stuck with. They should have, if the machine is capable of it, it should be able to print it.
Thank you. All right, does anyone have any questions for AON3D? Looking in the Q&A dialogue. Sean, do you have any questions for them?
Hey, Nicholas. How old is your company? When were you guys founded?
So AON was founded around 2015 by 3 material engineers out of McGill who were running essentially a print bureau out of their garage. They started modifying off-the-shelf desktop printers to print higher and higher performance plastics for their customers. And they soon realized that their customers were more interested in the printers they were modifying than the printed parts themselves. And so the founders pivoted the company to focus on the machines. And we are at our 2.5 design and product at this point with the AON3D 2020 and many more years to follow of product design.
Thank you. We've got a couple questions in. Thank you, Julian. How will AON3D be implementing or using Dyndrite?
That is still in the roadmap to determine. We are working closely with the Developer Council. I've been to 2 developer meetings, I believe, over the past 1.5 years now at Forum Next and Rapid, and we're happy to see the progress they're making and look forward to future collaborations.
Yeah, this is our first open live Developer Council meeting. So we definitely look forward to the next ones. Another one from Michael Galvez. Are you experiencing much warping during the printing process of high performance polymers?
So that all depends on especially your first layer adhesion, and also how you delaminate the part at the end of the print process, if you're taking into account any annealing. And it's all about working with experts to dial in the right settings when you start your print. Especially at the high performance side of things, a lot of materials have very specific geometry dependent process parameters that are required. Large parts will print differently than small parts, wide and flat. And working with a team of experts is the key to making sure that your parts come out the way you want them.
All right, last question from Kenneth Wong. Are there any specific 3D printers or materials that work better than others for printing face shield frames?
So right now you want something with high throughput. So that's why FDM is probably or FFF is the best technology at the moment for the 3D printing, because you can get that probably the highest throughput of any additive technology. You could go up to the polycarbonate range or even some forms of nylon to get some better sterilization and cleaning properties. It all depends on material selection that then matches your sterilization and cleaning protocol. So there's many, I want to call them matrices out there with material versus sterilization method. And that's why working with the hospitals directly to find out what sterilization methods they have accessible to them. Some hospitals will dump everything into a bucket of isopropyl. Others will use ethylene oxide. Others will use gas hydrogen peroxide. It depends what the frontline health workers have available to them, and that's why selecting your material and working directly with them in that design cycle is key to success.
Thank you, Nicholas. Those are all really great tips for moving forward. All right, again, if anyone would like to keep chatting with Nicholas and the AON3D team, please join them in their vendor lounge starting at 12:30. All right, I'm gonna bring on our next presenter. I'll see you, Nicholas.
Thank you very much, Sarah.